All right, good afternoon. This is Python in 10 lunch break session. This is session 4, and because we've been a little bit off, I'll cover section 7 and 8, and I'll create an additional session of 9 and 10 for next week. I'll get started by sharing my screen. Let's see. I share this. Okay, that should show up. Great. So again, bite-sized guides. So we're going to jump right into lesson 7, linking data. So in last session, we looked at different ways to edit data, including managing whitespace content, deleting content, changing content. Now we're going to link data from different files together, which can be very helpful, very useful. There's a variety of things we'll do. I'll link state names to abbreviations using 3 different methods. Then I'll link 2 files together where not all records are the same. And then finally, 3 files together by sequence number where not all records are the same. So the data sets I'll be using for lesson 7, there's going to be some state data sets. There is US state population. It's a CSV file, which just has abbreviations and then the population of each state. Then there's US state abbreviations, which has the abbreviation column and then the full name of the state. And we'll be doing a lot to combine these 2 data sets to start with. And then we have this US state brain cancer rates, which are abbreviation of the states and then incidence of brain cancer, both total and then separated by male and female. And a caveat of this is not all states are included, so this has missing data. So we're going to deal with that when we get to that data set. Then later on, I'm going to use data sets from NHANES. These are 3 data sets from the survey of 2017 to 2018. There's going to be 3. There's going to be a demographics data set, an Albium test data set, and the physical activity data set. They're all going to have the sequence ID. That's how we're going to link them together. The demographics has 25 other variables, so 25 other columns. Albium just has 2 other variables, and physical activity has 4. These all can be available on the Dakota Statistical Resource page under Python in 10. It's going to be the part 7, the data sets. You see here, it's going to be actually a zip file, these 6 data sets for Python in 10. Additionally, there is a text-to-file data set, Abe's name dictionary that I'm going to be using. This is a way to simplify having to type this all out yourself. So I'll show you where that comes up when I get to that section. Okay, with that, let's move this here. Okay, so let's start with easy example number 1. We're going to create a new file that has a full state name as well with our population data set. So essentially, we're going to link 2 files together. So you're going to need the first data set. That's the US state population. Let me pull that up just to show you what that looks like. CSV file. It's a very simple file. And of course, these easy examples, really, it'd certainly be faster to do this just by copying and pasting into Excel. But these are quick, easy examples to show you how you could do this for things that aren't simply as easy. And they're simple and small data sets, so you can check your work. So this US state population just has abbreviation for all the states, as well as the population. So very simple data set. So you're going to open up Python and start a new file, create a path and file variable. So as we've been doing before, path, wherever your path is to that US state population. And then the file is US state population.csv. And then we're going to create a dictionary called ab to name, so abbreviation to full name. And this is where that file comes in. So this is the link here. So it's going to be, let's see here. I'm going to add that to the chat. Let's see here. It'll let me up here. Nope, that's not. Let's see. Anyways, so there's that. And so that's just the text file of this, so you don't have to type this all out yourself. And so this is a dictionary. The key is the abbreviated two abbreviated letters for each state, and then the key is the full name. So if you have North Dakota, ND is North Dakota. With that, we're going to do an out file, so we can have this file that is US state population out. And again, make sure to have write, so it'll write it out. And then we'll start by doing out file, the method write, and we're going to create our headers. So we're going to want state, abbreviation, population, and this is going to be separated by commas because this will be a CSV file, and then have this white space, the new line, so \n. So that's going to create a new line. So the next thing we write to this out file, it's not going to continue on the same row. It's going to go to a new row, which is what we want. Then we're going to do a for loop for each line. So for this file, we're going to, as we've been doing pretty typically, if there's the headers, so if abbreviation is in line, that's part of the header, we're going to just pass over it. We only want to get to the actual content. Once we get there, we want to create two variables, abbreviation, population, just by doing the line split method by comma, because it's comma separated. And we want to strip off our new line from the last item in our line. So that's going to be population. So we're just going to redo population, having the strip method, so we don't have that new line. And then we're going to create a variable I'm going to call new line. We're going to add these things together. So and remember, we want to have the full state name. So we're going to go up to our add2name dictionary. So to get the full name, we're going to do add2name and then have our key of abbreviation. So if we add our ND, this will give North Dakota, then our abbreviation, so ND, and then whatever that population was from that original file. We'll put those all together, lining up in the same order that we had for our headers. So state, abbreviation here, and then population, and then a new line. So again, it continues on, and then we're going to write that new line to our out file, and at the end, close it. I'm just going to run everything here. Nothing should show up here because we're not really printing anything out, but then I'll show you what that file looks like. Let's see, it's going to be US state population out. Take that and see if that gets what we wanted. What's that? See if it's going to let me give Excel a chance to load. There we go. So this is exactly the file we want. We have the state line with the full state name, the abbreviation, and population. So that was very simple. All right, so that was one way to do that. Let's look at another easy example. We're doing the exact same goal, create a new file that has a full state name as well, but we're going to do it a little differently. We're going to use two files, using one to create a dictionary. So for the first time, we just use this custom built dictionary that we typed out by hand or copy and paste. Now we're going to actually use one of those files, that US state abbreviations.csv, and then the population CSV to create the third file. So this is that state abbreviation file. So that's the second data set. So again, it's just have abbreviation and state. We know that our first data set had abbreviation and population. So we can link the two together by abbreviation. So we're going to open our file 2, and then we're going to create a second dictionary. Now we're going to do it by hand, or we're going to do it with for loops. So add2name 2. So for line in this second file, again, pass over the headers, and again, create abbreviation and state by splitting lines, cutting out new line white space, and then adding to our dictionary with the abbreviation as the key and the state as the value. And if we just go, this has already been loaded or already been run. I'm just going to run 2, and we can see here that's it looks identical to essentially other than the order, identical to the one we did earlier. This one was just created using a file on the fly here. Okay, create a new out file 2, write it the same exact way. And this is essentially copy and pasting exactly what we did up here, except for it's going to be writing to using the dictionary apt name 2 rather than 1, and then writing out to out file 2 rather than out file 1. And when we take a look at that, out file 2, that should be essentially, it's the exact same as we saw from the first out file, state abbreviation population, just using a different method. And our third easy example is going to be the same outcome, the same goal, create a new file, but we're going to do it by using 2 files again, but looping through one file inside the other rather than creating a dictionary. So we're going to create an out file, new out file, population out 3, write our headers to that. Then we're going to go through our original file that has the population, again, pass over the headers. Okay, then we're going to create our abbreviation and population, splitting line, cutting out white space. That's been the same, but now we're going to create a variable called state, and we're going to keep it empty as an empty string. So just have 2, apostrophes, or you could have quotations. Then we're going to within each line of the first file, we're going to open up the second file. So we're going to call it line 2 in file 2. So that's the one with abbreviation, the full state names. And so we're not overwriting what these variables we've already created. I'm going to call these ones abbreviation 2, state 2. We're going to open those up. And then what we're going to do is we're going to check is if the abbreviation from our first file matches the abbreviation for the second file. And if that's the case, we're going to go to state. So essentially state's going to be filled out instead of being empty as the state 2 that we set here, and then stripping out white space. So what this does here, let's see if I can kind of show you. Let's see, is this the right? So that's the one file. It's the, no, that's the full one. We don't want that. We want, okay. So what happens is, what's going on here is we're opening this up, going through each line. So when we get to the first line, Alabama, we have this here. And then we open up the second line, and then we go through, and once this abbreviation matches the abbreviation of the line here, it's going to fill this state in as the state variable. And then we're going to put those all out on a new line and write that out. Now you could also, you see this is an if statement. You could also make this a little bit faster if you had an else statement that you broke, or an actually, no, you don't actually need to do that. You could break this anyways. That's getting above and beyond. We don't need to go into that. So really what's this going? It's going to create, by looping through these 2 files, a exact same type of output as we've seen before. State, abbreviation, population. And so, yeah, we just saw 3 easy examples doing the same thing, different methods. Now, depending on what you want to do, one of these ways might be easier or harder. And one thing to note for this example 3, this is, now since these are a very small data set, these are all essentially done instantaneously. But if you have very large data sets, this is a fairly inefficient way to do things, because you do a lot of looping that you don't really need to. So this certainly isn't the most ideal way to do it for a more complicated data set. Again, part 1, where we kind of had this created on our own, is also not very helpful for a lot of data sets. So something probably like example 2 is straddling the line between efficiency and speed, but really just depends on what your outcomes are. So we've done some easy examples. Let's switch to a little bit more complex example. Let's see, example 1. So we're going to do 2 files, but not all records are the same. So we're going to use the third data set, U.S. state cancer, brain cancer. So we're going to call that file 3. Create an out file. Now we're going to call it U.S. state brain cancer out. Write our headers. So this time we want state, abbreviation, total, male, and female. And just to remind you, so the state brain cancer, this has the abbreviation and then the incidence of brain cancer for total male and female. But what we want to add to this is going to be our full state name. So we don't want this. So we're going to want to link again to that first data set, which has, or sorry, second data set, which has abbreviation and full state name. So this one here. So we're going to open up our file 2, go through it, skip over, as we almost always do, the headers, create variables for abbreviation state, strip out new line white space. And then what we're going to do here is, because there's some missing data here, this is how I've set it up. We're going to set 3 variables, total male and female. So that's the brain cancer incidence by default as NA, so not available. But then we're going to open up a for loop within this for loop for our file with brain cancer, create variables. Again, we're going to increment to have them as 2 so we don't overwrite these original ones. We're going to split it out, strip out any new line white space. So again, like we did before in the simpler example, we're going to check if the abbreviations in each data set are equal. What we're going to do is we're going to create this total is going to be overwritten by total 2, so the actual incidence from the cancer data set. Same with male and female brain cancer incidence. Now, if it goes through and it never finds a file, if there's going to be some missing data. So if a state is not available in the brain cancer incidence, what's going to happen is this is never going to be overridden, and so it's going to stay at the default of not available, which is exactly what we want. So we'll write out the new line up at the same level of everything else here, not indented in the second for loop. We're going to have state, abbreviation, total, male and female, again, matching those column header names. So we get things in the right column, write out the out file, and then close it. And what that looks like is very nice here. Okay. So with this, we have what we want. We have the full state name, the full abbreviation, and then the brain cancer. And we can see here when states show up that did not have an entry in the brain cancer file, we have the NA. So it looks like there's that for that. Delaware, Illinois, Kansas, Kentucky, Massachusetts, and Pennsylvania. So we're able to combine data sets that weren't of the same size and include information that wasn't available, or information as not available. So that's all well and good, but I think what we should do here now is an even more complex example by combining the three NHANES data sets. So we want to make sure we have our 4th, 5th, and 6th data sets. We can set them as variables. File 4, 5, and 6 will be demo, albium, and PAQ, physical activity. And we want to create a new out file. I'm going to call it demo underscore alb underscore PAQ underscore out, write to it. And we're going to create 3 empty sequence dictionaries, 1, 2, and 3. And then, so what we're going to do here, we're going to start with a for loop for file 4, the demo. So that's demographic variables. So we're going to go through and we're going to check if sequence is in the line. So if the sequence is in the line, that means that's going to be a header. So I'll show you what this looks like, this data file, or this data set looks like from NHANES. Pop up, so it's going to have a sequence, and so this is sequence, and so this is how we're going to link the data sets together, and then it has a bunch of variables. It has, I think, what, 25 other variables with various entries. So if we find sequence in the line, that means that's the header. And so what we're going to do here is we're going to just write this whole line, stripping it of the new line white space, which will be important. So then in our out file, we'll have all this here because we're going to want all this information, but there won't be this invisible new line. So when we add something else here, we can keep adding this way to add more headers, which will be important because we're going to have headers for the other data sets. So if it's not a header, we're going to, first of all, create a variable called sequence, line split, and we know that it's the first one here, looking at our data set. So we're gonna have the index of 0. And then what I'm gonna call a new variables, I'm gonna call column name. So that's the rest of the names of the columns, or the rest of that fill from other columns. And since we know it's actually gonna be a list, we're gonna split it by comma because it's comma separated, but then we're going to use this format here. It's going to be 1, so it's going to start at index 1, so right here, and then I'm going to have colons, and then since this nothing is here in this other colon, it's going to go all the way to the end. Theoretically, I could also put, I think, -1 to also show that. And then speaking of -1, to make sure I don't have that new line white space, I'm going to set this up at column names, and then the last entry of column names of the list, that's going to be this this variable here. We're going to strip that of its new line white space. And then what we're going to do is we're going to add these to our dictionary 1. So the key is going to be sequence, and then that list of column names is going to be the value. And so if we just look at this, what this looks like is seq dictionary 1. I should actually run this. Okay. All right, let's go seq dictionary 1, and then I'll just use the last entry that was the sequence. Oh, that's not defined. So let's just take a look. Let's grab this first one here. So that's the sequence is the key, and then the value. Okay, that's not working here. Oh, I wonder. Okay, well, I guess we won't take a look at the data set or the dictionary for right now. Well, let's see. Seek. Why don't we just oh, you know what? I was spelling that wrong. Now let's try. There we go. So for and sequence was the ID of this one, and then we can see here this is a list of all those entries, wherever it was on the sequence. I think it was the one at the bottom, because that was the last one made. So we have a dictionary with all our sequences as keys, and then all the information in the rows, the rest of the rows, as the values. So we're going to do that same sort of thing for each of the files. So file 5 and file 6. Check if the sequence is in line. And now, because we don't want an additional column in our headers, we're going to make a variable called line2. We're going to strip sequence out and then just write to our out file line2 with the strip 2. So then what this is going to do is it's going to add the additional 2 headers from this sequence to our out file. Then in the else, same sort of thing here. We're going to essentially all we're going to do here is with our sequence dictionary 2, we're going to have our sequence and then the values for the columns as that. So I'm going to just look at see if we can do, if this is going to let me do it. Okay, so it just had 2 variables, so that's what that looks like here. Same thing for the 6th file. Again, we're going to strip this out so that we only have see if I can show you what the end of line 2 looks like. Okay, so it's only going to add the variable, the header names and not the sequence names, so we don't have overlap. And then and now since I don't need to strip the new line because this will be the end of mine, I'm just going to keep it as is and write the whole line 2 out there. And again, adding adding the information on the lines to the proper dictionary. So now we have 3 dictionaries with sequences as a key and then the information on the lines. Now let's put them all together. think, let's see here. Okay. Okay. Okay, we're still here. All right, so now we've done that. So we're going to go through these dictionaries. So we're going to start with a for loop for sequence in the first sequence dictionary. I'm going to create a blank variable or an empty string for a variable I'm calling out underscore line. Then I'm going to have list one, which is going to be the sequence dictionary sequence. So that's going to be that list of all the entries that are in that sequence dictionary. Then I'm going to check. So if sequence in sequence dictionary 2, because these 3 different files, not all the sequences are on all the files. So I'm going to check if the sequence from the first sequence dictionary is in the second dictionary. If it is, I'm going to call something called list2 with this information. Otherwise, I'm going to, because I know there's going to be 2 entries, I'm going to create a list2 that has them as NA, so not available, so missing, sort of like we've done before. I'm also going to do an if-else loop, check if the sequence is in sequence dictionary 3. If it is, great, we'll just call list3 that information. Otherwise, we're going to just keep them as 4 entries of NA. And then I'm going to have what I'm going to call list. So this is a list of lists, which is going to have the list of 1, 2, and 3. So let's just look at the first entry of list here. So it's going to have, let's see here. Okay, actually, I think we just do here. Okay, so you see here, this is one of the entries of list. So it has the first list with the 25 variables, the second list with 2 variables, and then the third list with 4 variables. Then we're going to go through this list of lists. So for L, list and list. And again, you can name this whatever you want. I found list. Maybe it's a little odd, but it helped me keep in track. This is a list of lists. So for list and list, so it'll start with this first list. And then I said for I in list, so for each entry in list, we're going to build it into our outline, which is initially empty. We're going to do outline plus I. So how this setup here is, it starts with what's already an outline. So the first time it goes through, it'll just be blank. So it's going to add I, so this first entry, and then we're going to add a comma because we want this to be a string of comma separated values. And it'll keep doing this. And so the next time it gets through this, it'll already have something in there. So it'll keep that and then add the next thing on. So we have every item in here separated by commas. Now, since we kind of had this, we'll have a trailing comma at the end here. I'll use this line outline, and then I'm going to just take this out by just subsetting it by everything minus the very last setup. So we can do 0 to -1, which will have everything but the very last character, which is an extra comma that we don't want. Without all that being there, I'm going to just show you what an outline looks like. You can see here, it's a very long line of comma separated values. We're going to write that to the out file. We're going to do the sequence first, plus a comma, and then outline, and then a new line. And when we do that, a bunch of times that's going to fill out our new file. And what that new file looks like is, what would we call that? Demo, okay. We're going to link together all the information from the 3 different data sets into a single file that was linked together by the sequence. So we see here, we have those first, 25 variables from the first data set, but then we have the 2 columns of variables from the other data set, and then the 4 variables from here. So those 3 data sets are all linked together here, and this would be really hard to do by hand. And of course, there are some variables that were missing in these smaller data sets that now are available as NA, just sort of the format that these bigger data sets have. So that was how we combined those all together. Thus ends lesson 7. We found that we can link different data in a variety of ways. and they can be compared to lines of another file and written together. You can store in dictionaries, or you can compare them to lines in a file, or you can even use multiple dictionaries, each one compared to another and written together in a new file. So that's a very handy way to combine data sets by linking it based on shared characteristics between files. So now let's take a look at transforming data. We want to examine how to transform a basic data set from wide to long, transform a more complex data set from wide to long, and then a basic data set from long to wide. So I'm going to comment this out. Let me comment out, and I'm going to uncomment this information. Okay, so the data sets we'll use. 3 data sets. We're going to use low poly wide. This is a data set of 14 low poly pine trees with 6 columns of growth measurements. Transform a data set found in R. So here's seeds and then various heights at ages. There is the SEER Cancer 1 CSV file. It's a data set of cancer incidence, consequence regions, 3 cancer types in 10 years, and then cabbage long. It's a data set of 60 cabbage plants. Observation of 4 variables from the mass package in R. So you can get those from Dakota, and they're under Python 10 Part 8, low poly, cancer, and cabbages. All right, so when I talk about wide to long data sets, so wide data sets like this typically, like I said, are wide and often have redundant information, whereas long data sets typically each observation is like usually a single entity, a single observation, and then instead of having, say, something like this where we have height 3, height 5, there's going to be one height data set, and then this 3, 5, these are years. It's going to be a categorical data set of age. So we'll see how that kind of goes as we go. And different analyses require different types of data. Typically, long data sets are more commonly used, but sometimes you might need wide data sets for, say, something like a paired t-test is the most common example. And so let's load in the data. So again, you need to create a path file, and then wherever you saved your files, we're going to do low poly, SEER, and cabbage. I just name them file 1, 2, and 3. So that's pretty straightforward. So basic wide to long. We're going to transform the low poly data set from wide to long. So we're going to create I'm going to do something a little bit different with headers. I'm going to create a variable I'm going to call new headers 1. And we're going to set equal the string of the headers that we use for the transformed file. So the file right now, what it looks like is, let's pull that out. So this is going to be, so it's a wide data set. And we want it to be long. The wide data set is going to have, looks like 6 columns. We're going to actually have, for the long one, we just want 3. We want height, age, and seed. So seed will be the same, but then height will be all combined into one. And then we'll create a new variable called age that captures this information of 3, 5, 10, 15, 20, and 25 years, rather than having that information out in the header of those variable names. So create an out file like we've been doing before, and then we'll write our new headers to that, plus a new line white space. Then we'll loop through our file, the low poly pine wide data set. So again, we're going to pass over the headers. Else, we're going to, for each of those variables, we're going to create a variable in Python. So there's going to be seed and then height 3, 5, 10, 15, 20, 25, split by line, strip out white space for the last item in the line, height 25. So then we're going to create a list, which I'm going to call height list, which is going to have these variables that we created here from 3 to 25. And then we're going to have an age list, which is going to be a list of strings, 3, 5, to 25. And so now what we're going to do here is we're going to do a for loop for I in just this sequence 0, 1, 2, 3, 4, and 5. I'm sure there's more Python ways to do that, but this is kind of the clearest way I had to go from essentially go through 6 times because we have 6 different heights. We're going to write an out file. We're going to write the height, age, and seed based on the index of the list. So for the first I, it's going to be 0. It's going to write out whatever variable was in height 3 that we had here. And then we're going to have age list. So that's going to be 3 here. So that's going to be our categorical variable name. And then the seed. And so when we run this, what it looks like is going to be a long data set that has 3 variables. And there we go. So we have now height here, age, and seed. And so you see here now that seed shows up 6 times because instead of having a line for each seed and then having a bunch of heights, we have heights on each line. And then I created this new variable having those age pulled out from what we knew of the information of the long data set or the wide data set of ages 3, 5, 10, 15, 20, and 25. So this is a little bit easier to analyze for a lot of different analyses. So that was a fairly basic wide to long setup. Let's look at a more complex wide to long. We're going to transform the SEER data set from wide to long. So let me pull out the SEER data set to show you what that looks like. Okay, so from wide to long. Okay, SEER1, Cancer1. So we want to create a new headers file. So what it looks like, and this is pretty messy, which is going to make our cleaned up data set a lot nicer. We can see here that it's kind of confusing, but this first column here is the different SEER areas, so these different geographic areas. And you see here there's some blank spaces. So that's kind of confusing. And then we can see here there's 3 different types of cancer incidents: lung, melanoma, and pancreas. And then the year is above here, and then it repeats. So it goes up to 2008 and the 3 different cancers. So we're going to try to incorporate all that into a new long data set that has the right headers that we want and everything. So I'm going to close the lowbully. All right, so our new headers, our new data set is going to have four columns: region, cancer, year, and rate. Open a new out file, write a new headers plus a new line white space. We're going to open up a for loop, run through. So if region is going to be the first item of our line split, and so it's sort of confusing because this stuff is empty here. So we're going to get around that, and we're not going to deal with that by doing this little setup. So we're going to check if the length of the region is what the size is. If the length is less than 2, it really could be less than 1 or less than really anything. We're going to pass. So what's going to happen is for this if loop, if we hit one of these areas, which are blank, we're not going to do anything. Only when we hit regions that the length of the region is greater than 2 characters. So really any of these, because these are more than 2 characters, we're going to set this up. So we're going to create a line list. So it's going to split the lines from 1 to -1. And then the line list, we're going to strip out the white space by using the last item in the list. So what the line list looks like. So, I guess I need to run this first. Let's see here. Let's see, line list. Okay, so that's going to be all those cancer incidents in a list for each line and then stripping out the white space. Then because we know how it kind of regularly repeats, we know that starts with lung, then melanoma, then pancreas. We're going to create a C list, a cancer list with the headers for these. And then we're going to start at year, because we know that this starts at year 2007. So to kind of get this information, what we're going to do, we're going to create a variable called ID. We're going to start at 0. So we know that our line list, so we're going through each rate, are in the line list. So these ones. So for each rate in here, we start at this one here. We're going to call a variable cancer whatever is on the C list. So since ID is 0, the first one is going to be index 0 of the C list, which is going to be lung and bronchus, which matches this first setup here. So then we're going to outfile, write to our outfile, our region, which is going to be whatever was here, our cancer, which is going to be lung and bronchus, our string of year, which we set at start at 2007, so it's going to be 2007, and then whatever that rate was. So it's going to be this information here. So that's that first thing. Now we're going to up the ID by 1. So the next time we come around, the ID is going to be 1. So then we're going to write out the cancer is going to be melanoma of the skin. And so that's going to do that same year. And then the rate is going to be that. We'll keep doing that until we get to ID 3. If ID equals 3, what happens is that means we got to the end here. We're going to actually reset the ID to 0 and then increment the year by 1. So then next time we go through, we'll start out putting 2008, because year plus 1 of 2007 is 2008, and then ID is 0 again. So then when we get our cancer out, we're going to start at 0 again. And we're going to keep going and doing this until everything is done. And then what that has the outcome of is making sure that every region will have information on, so here we go here, of the cancer, year, and rate. And so a lot of information is much cleaner in a long data set here. And so that's how we got that long data set. Save. Okay, so there's that. That was a more complex wide to long. Now we'll finish up with a basic wide to long data set. Now, yeah, it's less common to go from long to wide, and it's actually harder to go from long to wide, so just a heads up. We're going to transfer the Cabbage data set from long to wide. I just want to do a little bit of caveat. The wide data set used here has 20 observations, which each observation having 3 weight variables. Each of the initial observations was actually a different plant. So it actually is not 20 plants that at 3 time periods. So the wide data set wouldn't really be appropriate if you're going to do an actual analysis. So this is just for the purpose of an example. So that's that caveat out of the way here. So what does our data set look like? So we're going to go from long to wide. So what our long data set looks like here is from cabbages. Okay, so there's cultivar, there's date, head weight, and vitamin C content. And we want to have a wide data set. So we're going to create new headers called ID and cultivar we still want. But then we want, instead of weight at our head weight and then date in different ones, we want to combine this. So we're going to have a column with weight at 16, at date 20, and at date 21. And we're actually not going to deal with vitamin C because that complicates things, but we theoretically, if we really wanted to, that we could create 3 more variables, vitamin C at 16, 20, and 21, and add more code, but we're just going to drop the vitamin C for right now. Okay, so we'll create a new out file called cabbages wide, add the headers to that, and we're going to create an empty cabbage dictionary and then a variable called n that will start at 1. So we're going to do a for loop for this line, lines in the file 3, so that cabbage's long data set here. So if head weight is in line, so that's going to be the headers, we're going to pass. Otherwise, we're going to create variables for each of these things, though we won't actually use vitamin C. I just did create a variable here in case we wanted to modify the code later, but cultivar, date, and head weight is going to be the important ones. Then we're going to set our ID to n. So that's going to start at 1. We're going to create a for loop for each line. So what we're going to do is if date equals day 16, we're going to create a key, a variable I'm going to call key, and we're going to call it weight day 16. Same thing for if day is 20, we're going to have a key that goes weight day 20. Else, so this is the elf. So this is a if, else. So that's a way to do three different setups. And then the key is going to be weight day 21. And so those keys are going to be important for later. And then I'm going to have something called observation. I'm going to have it as a string ID plus this and spacer, and then whatever cultivar was. So what that looks like, so observation, so it's going to be this. This just helps keep things separate, tell things apart. So we're going to have this cabbage dictionary. We already created a bunch of keys. And so we're going to ask if our observation is not in the cabbage dictionary, we're going to add it to that. And the variable observation will be the key here. And then we're actually going to create a nested dictionary inside that using the key value pair as the key being the key we made here, and then the value being the head weight. So if observation is already in there, we're going to use the variables key and head weight as to add to that nested dictionary. So to add to a dictionary, you do, the name of the dictionary, the key, and then you would just have this out here. But since we're actually going to a dictionary inside a dictionary, we're going to need to do this a bracket and then the bracket of the nested dictionary to create a additional entry into that nested dictionary. We're going to increment our n plus 1. And then if n equals 11, we're going to reset it to n. So what that's going to do is, I think then, I think we have, that just keeps track, I think, because we have cultivars. I believe what it goes is, yeah, because we have 2 different cultivars, we need to reset things. Okay, so then again, this is much more complicated from for long to wide than wide to long. But so we have our dictionary, and so let's look at what this looks like. Cab dictionary. Okay, and so there's a lot going on here, but then we have these keys for each of our observations, and then a nested dictionary with the different weights for our different weight days. And so that's for all of those. So then what we're going to start is create a for loop for each item in the cabbage dictionary. So it's going to be for each of these observations. Right, yeah, because the n was, there was a certain number of observations. There's 10 observations for cultivar 39 and 10 observations for cultivar C52. That's why we had the n. So for each of these in the dictionary, we're going to have these variables ID cultivar. So we're going to split this information out by the, what is it? I forget the symbol for this, whatever the symbol name is, the spacer or whatnot. We'll still separate that out into separate variables, and then turn the ID into an integer. And then if cultivar equals C52, we're going to add 10 to the ID. So then what that's going to do is, instead of having, so for the first 10 observations, going to be the ID is going to be 1 through 10, but then we don't want to repeat that. So we're going to, for the second set of cultivars, we're going to add 10. So it's going to be 11 through 20. That's kind of what this red thing or green box talks about. Okay, and then we're going to set 3 different weight day variables as the variables from the nested dictionary for each of the weight day keys. So weight day, these variables, weight day 16, 20, 21 is pulling that information out from this nested dictionary. Then we're going to have our line, which we're going to send to the out file in just a second here. We're going to have our ID. We're going to turn back into a string. These are comma separated. We're going to have our cultivar. We're going to have our 3 different weights, and then write that out with a new line. And at the very end of this, just a couple of pages of complicated sort of things, we're going to finally get our Y data set. And behold, this is what we wanted. We have weight separated out by the different days. ID here, that's a variable we created just to keep track of things, and then the 2 different cultivars. And again, this is just for illustrative purposes. You won't actually analyze this because this row here isn't actually a single plant with ID of 1. It's actually 3 different plants of this cultivar at different days. So that's really why it was better at long. But had this been 20 plants measured 3 times, this would be a way to get it rather than this actual 60 different plants. Okay, so that was how we did long to wide data sets. Now, just caveat, data sets are a lot easier to go from wide to long than long to wide. And this is just one way to transform your data in Python. I'm sure there's easier Python ways. And many other software like R and SAS can do it much more quickly and efficiently, but it's often edifying and useful to see how you run transformations by hand in Python. So hopefully that was helpful. That concludes this part. Now, we didn't get to 9 and 10 in the 4 weeks, so I will create an additional training and should also record that as well. So until next time, have a great day, and hopefully this lunch break session was illuminating.
Illuminating is correct.